The first drill hole, we're drilling it in the northwest corner of the Ross Ice Shelf, which is the marine floating extension of the West Antarctic ice sheet. This is what the core looks like. Very simply, we have three types of rocks here. We have the green ones that stick out the furthest, and these are the glacial rocks that are deposited when the ice sheet is grounded on the seafloor at the drill site. And they represent full glacial conditions like we had during the last ice age. And the intervening yellow units represent periods where there was no ice. So these represent the deposits of marine algae that were flourishing at this time when it was perhaps warmer than today. So what you see here is this dramatic alternation between glacial conditions and conditions that are actually warmer than we have there today. And the West Antarctic ice sheet was probably very small, perhaps only 5% of its present size. The hope was we would get a good enough record to see fluctuations. But what actually came out of that hole had our eyes out on organ stops. We were just staring at this core and seeing these dramatic changes in environment from full-on glacial conditions where you had glaciers grounded right out on the Ross Sea. So these are big ice sheets sitting in the Ross Sea. And then just over half a metre of core or less, wham, you're into green diatomaceous ooze. So you've heard of diatom blooms, how we get these algal blooms. Well, that's what it is. And the characteristics of many of these blooms indicate it was warm water, an open Ross Sea. Temperatures were 2 to 3 to 4 degrees warmer than they were today. And we're starting to build a picture of a very different Ross Sea, Antarctica, West Antarctica during some of these warm periods in the past.
What we're trying to do down here with drilling is recover sedimentary records, sedimentary archives that give us a history back in time of where we may be going, where we're going into the future. Antarctica, if you look across here 5 million years ago, you'd see no ice in the sea. You'd see not so much ice on the hills. You might see green over there, right? And periods where the ice is not freezing in the oceans as well.
So essentially what we're really seeing on this core is the complete retreat and ultimate, if you like, demise of the West Antarctic ice sheet. We didn't see that once. We saw numerous cycles of advance and retreat, of growth of the West Antarctic ice sheet and then loss of the West Antarctic ice sheet. Okay, so what we have here is obviously a map of Antarctica, but it's a map of ice sheet thickness. So this is the present day configuration of the ice sheet. The colours represent thickness. The redder colours are thicker, so this is 4,000 metres thick in the middle of the East Antarctic ice sheet. Now, our drill site is down here in the northwest corner of the Ross Ice Shelf. And you remember the dramatic variability we saw in the rocks, indicating major changes in this ice shelf coming and going, and the West Antarctic ice sheet coming and going. So what we're going to do now is we're going to warm up the climate. We're going to see what happens, particularly to this part of the ice sheet, and see if we can simulate what we were seeing in our drill core record. If you'd like to start the simulation. So look what happens to the Ross Ice Shelf firstly. And then you'll see, right, so that disappeared dramatically, and that is followed by this dramatic retreat of the West Antarctic ice sheet. That low-lying interior of the West Antarctic ice sheet is gone. Watch again, very quickly through the Weddell Sea region, eating back into East Antarctica. The Weddell Sea and the Ross Ice Shelves, once they go, there's no hope for the ice sheet. And this is this buttressing effect of ice shelves. Take out the plugs out of these big embayments and the ice streams just flow out.
Going back 15 million years ago, you'd see a whole different biota down here. You'd probably see porpoise and dolphin swimming out there rather than killer whales. This place has changed.
So I guess what concerns me, what worries me, is when I look at this record, I think we're able to form a picture of, okay, crank up the CO2 to 400 parts per million, increase the temperature of the atmosphere 2 to 3 degrees, and you won't have a West Antarctic ice sheet.